Hello students, welcome to my YouTube channel. In this video, I'll be discussing the questions of the chapter Real Numbers which has occurred in the year 2023. The question is, two numbers are in the ratio 2:3 and their LCM is 180. What is the HCF of these numbers? This question was asked for 2 marks. So, whenever the question is given, first we have to record what is given in the question. So, given is two numbers are in the ratio 2:3. So, numbers are in the ratio 2:3 and their LCM is 180. So, LCM is given. LCM is equal to 180. They're asking us to find what is the HCF of these numbers. So, to find HCF. So, in order to find the value of HCF, we first have to find the numbers because here it is given in the ratio. We have to find the numbers which is given in the form of ratio. How to find the numbers which is in form of ratio? It is very simple. So, whenever the numbers are given in ratio, we have to take that. Let the two numbers be 2x and 3x. So we got the two numbers as 2x and 3x. Now what will be the LCM of 2x and 3x? LCM of 2x and 3x. How to find this? Very easy. So I can write 2x as 2 into x and 3x as 3 into x. So from this LCM is 2 into 3 into x. So LCM is equal to 2 into 3 into x. So I got the LCM as 2 3s are 6. So 6x. So the LCM of 2x and 3x is 6x. But they have given in the question that LCM of the two numbers is 180. So I can equate 180 to 6x. So I'll be getting 180 is equal to 6x. From this I can find the value of x. How? I can transpose 6 to left hand side. I'll be getting it as 180 divided by 6 is equal to x. After further simplification, 6 ones are 6, 30s are. So 30 is equal to x or the value of x is equal to 30. So I got the value of x as 30. Now it is easy for us to find the numbers. So the numbers were 2x and 3x. So we'll first find the first number 2x. So it becomes 2 into 30 which is equal to 60. The second number was 3x which is equal to 3 into 30 which is equal to 90. Now the two numbers are 60 and 90. Two numbers are 60 and 90. So now it is easy for us to find the value of HCF using the formula. We know the formula that LCM of the two numbers into HCF of the two numbers is equal to product of the numbers. So here in this case the numbers are 60 and 90. So we know the LCM. We know the two numbers but we need to find the value of HCF. So what we will do, we'll transpose this LCM to right hand side. So HCF of two numbers is equal to A into B divided by LCM of these two numbers. Here the two numbers are 60, 90. So now I can substitute the value of A as 60 and the value of B as 90 because we found the two numbers as 60 and 90 divided by LCM of the two numbers given in the question is 180. So after further simplification I can do this as, I can cancel 0 and 0. So what is left out? 60 into 9 divided by 18. Now further simplification I can simplify here, 9 ones are 9 twos are. So I will be getting 60 divided by 2. Next I can even more simplify this as 2 ones are 2 30s are. So the answer is 30. So we got the HCF of two numbers, that is 60, 90 as 30. HCF of the two numbers, HCF of the two numbers 60, 90 is equal to 30. So this is the answer for the given question. Yeah. Now one more question asked in the previous year paper is, prove that root 5 is an irrational number. So this question was asked for 3 marks. So how do we prove that root 5 is an irrational number? Let us see how to do this. So we have to prove that root 5 is an irrational number. In order to prove that it is irrational, we'll go with the contradictory method. That is, we will assume that root 5 is an rational number. So let root 5 be a rational number. A rational number. So now we know that root 5, we have assumed it as rational number. I can write this as root 5 is equal to P by Q. Because rational numbers are the numbers which can be represented in the form of P by Q, where Q is not equal to 0 and P, Q are co-prime numbers. They are co-prime numbers. P, Q are co-prime numbers. So no need to worry about this word co-prime number, students. I'll just brief out what is this co-prime. The two numbers are said to be co-prime. That is, if I consider the two numbers as P, Q, these P, Q are said to be co-prime numbers if their HCF is 1. P, Q are co-prime if the HCF, that is, if the common factor between P, Q is between P, Q is 1. So if the common factor between P and Q is 1, then they are said to be co-prime numbers. So let us proceed with the proof. Now we have written that root 5 is equal to P, Q. Let me transpose this Q to left hand side. It becomes Q root 5 is equal to P. Now squaring on both sides, I'll get this as Q root 5 whole square is equal to P square. So this square is applied to both the digits. So here I can write it as Q square root 5 whole square is nothing but 5, which is equal to P square, or I can write this as 5Q square is equal to P square. So from this, what can I conclude? I can conclude that 5 divides P square. We have written that 5Q square is equal to P square. This implies that 5 divides P square. If 5 divides P square, based on the theorem, we can write that 5 divides P. This is the very important statement. 5 divides P. Here we have written it as 5Q square is equal to P square. Let us take this as equation 1. From this equation 1, we have written that 5 divides P square. From the theorem, based on the theorem, we can write this as 5 divides P. So now we are done with the first stage, 5 divides P. So from this we can write, let P is equal to 5C, where C is an integer. Now we'll substitute the value of P is equal to 5C in equation 1. So substitute P is equal to 5C in equation 1. So after substituting, the equation becomes 5Q square is equal to, in the place of P I can write it as 5C whole square. So for the simplification, 5Q square is equal to 5C whole square. It is applied for both the digits. So 5 square C square. So 5 square is 25C square. So now I can transpose this 5 to right hand side. I'll get the value of Q square here. Q square is equal to 25 by 5 C square. To simplification, Q square is equal to 5 ones are 5 5s are. I'll get 5c square. So what does this implies? This implies that 5 divides q square. I can write here it as 5 divides q square. So based on the theorem, if 5 divides q square, I can write this as 5 divides q. This is my second important statement. The first important statement was 5 divides p. The second important statement I got here is 5 divides q. But what did we assume in the beginning? We assumed that p and q are co-prime numbers such that the common factor is 1. But here we are arriving at 5 divides p and 5 divides q. This implies that p and q has common factor 5. P and Q has the common factor 5, but we have assumed that P and Q has the common factor 1. So this tells that our assumption is wrong. That is, P, Q are not co-prime numbers. They are not co-prime numbers. This contradicts our assumption. This contradicts our assumption that root 5 is rational. Therefore, root 5 is an irrational number. So this is the proof for the given question. Very simple. You just have to get thorough with the theorem and with the concept. Thank you for watching my video, students.